Hello, it's in the edit me, yeah? I was unsure about putting this out. I'm not sure where it's going, right? This is very much voltage optimization from an electrician's point of view. Now, you need to watch this video in conjunction with this video. This is a video by Big Clive. If you don't know who Big Clive is and you're watching me, you're missing out. Because if you like what I do when you watch my videos and you enjoy them, you'll definitely enjoy Big Clive. I do not see the point in reinventing the wheel, yeah? I could take this video and a load of the knowledge I've gained from it and incorporate it to my video. That's just ridiculous, yeah? This video by Big Clive is very much based on the product of voltage optimizers and goes into the product and the design and the insides. My video is about it from a sparky point of view. So you want to get a cup of tea, get really boring and watch these one before, one after. It doesn't matter what order you do them in, but the package you'll get from that will tell you everything you need to know about voltage optimization. See you in a bit. It's recording. Someone's asked me if first of all, this is actual. I'm hands-free. I should have done that another way. Hang on, wait there. This is actual. The camera size, I have to scroll for. This is actual electrical content. The washing machine's on the background, so if you hear any funny noises, it's not that. It's that, yeah. I ain't got the missus tied up down here in a bag ready to dump in the sea. But someone's asked me about voltage optimizers, right? And they want to know, so I may as well answer it now. This isn't going to be like, I don't think this will make it onto YouTube's video, or maybe... Well, it fucking has. Talking like a man that's trying not to produce 52 videos a year. Voltage optimization. Where do you start? Well, I started reminding myself by going on Wikipedia, so I'll talk about some of the stuff that's on there, yeah? But generally, the concept of voltage optimization is that your devices, the concept is your devices are designed to work on a certain voltage, and that is the optimum voltage for them to work on. But the reality can be very, very different. For example, in the UK, the optimum voltage, well, it's not even the optimum voltage, the actual voltage, actual electrical voltage is 230 volts. You may remember from school, you thick bastard. So on Wikipedia, I'm going to work this off Wikipedia. The reason I work it off Wikipedia is it's a resource that everyone can access, and I'm trying to bring up some discussion points. So I'm going to work on this Wikipedia article. I'm not going to start looking at fucking manufacturers' websites because they'll be fucking like eFix full of paid shit. I'm not going to start looking on fucking people who win tinfoil hats websites because they'll be saying they make you have kids with 7 heads. Everyone knows COVID was invented by a pharmaceutical company. Don't they, sugar? Gotta go and see Elvis now. I'm going to use this Wikipedia article because all the nutcases and advertisers have come together and united here. So as we know, in the UK, electricity quality and supply regulations, yeah, the voltage can be is 230 volt. Let me read this. Plus 10 minus 6. That's what you're going to get. So that's anywhere between 216 and 253 volts, which is a fair old range, yeah. Write that down, look at the Wikipedia and do the maths for yourself. That's a decent range. Apparently, the optimum voltage for your appliances is 230, and they do that because they're making them optimal for that voltage, because the concept was we brought our voltage down, so it used to be 240, and Europe used to be 220 or something like that, and they brought theirs up, meaning that manufacturers could knock out a microwave, which is what I'm saying, is what I'm looking at in my kitchen, and then they could sell it all over Europe with a different plug on. That's a great idea, right? There's absolutely nothing wrong with that. We brought our voltage down slowly over a number of years. They took their voltage up slowly over a number of years. It's probably fucking... They probably cross over anyway on the tolerances. And now everyone can make a microwave. Do they actually engineer that microwave to work? Pucker super duper at 230 volts. Pff, I don't fucking know. You know what I mean? I don't work in product manufacturing. If you can make it cheaper and optimise it to work at 220 volts, it's going to be fucking optimised to work at 220 volts. So straight off the bat, the concept of voltage optimisation is skewed because that means that every product you get has to be optimised to work at 230 volts, assuming you're working in the UK and your voltage optimiser will pump out 230 volts. So let's look at the type of loads we're going to come across. In a house, in a normal house now, you're going to get the following items. You're going to get lighting, yeah? Lighting is a given. However, it's a bit different than what it used to be. Lighting now is probably LED. The vast majority is LED. No one's using filament lamps anymore. So it's going to be LED, which throws it into the electronics category of switch mode power supplies and that kind of thing, yeah? Then you're going to have, so lighting traditionally would have been basically heating. It would have been heating up filaments. It's not like that anymore. Then you've got heating, ovens, electric heaters. They're just going to be Billy Basic coils, a thing that get hot when you put voltage through them. Yes, that's the other one. Then you've got general power. Well, most of the general power in your house, in my kitchen now, the toaster, that's fucking heating. The air fryer, that's heating. The washing machine, that's electronics now. That's inverter driven. Can you see the rabbit hole we're going down here, yeah? Traditionally, even the on-site guide now that still recognises 100-watt filament light bulbs, heating, lighting and power. Most heating is just fucking coils that heat up, yeah? Heating is 100% efficient. Remember that. That is the fucking base of all physics. All heating is 100% efficient. If someone tells you they brought out a new super efficient heater, they're lying. They're fucking lying. All heating is 100% efficient. It always has been, and it always will be. You cannot take electricity and make it basically melt into heat without all the electricity being turned into heat. It might not be efficient, but it's very, very... Oh no, it is efficient. It's 100% efficient. It might be very efficient at heating your house, but it's 100% efficient in the transfer of energy. So I can say to you straight away, 100% efficiency. That's whether you've got the best heater in the world or whether you put a bit of wire over a battery terminal. Anyhow, I need to rein this shit else. It's going to end up being a YouTube video. So, you've got your heating in your house. You've got your lighting. You've got your power. Let's just focus on a modern house now. A modern average house. Heating, oven, toaster, kettle, heaters, lighting, mostly LED. I would imagine the vast majority of it is LED, unless you're like pissing money at the wall. Small power, very small usage, electronic goods with electronic power supplies in them. That's it. That's what I'm working on. That's what the rest of the video is based on. Fuck me. We're like 6 minutes in here and we haven't even fucking started the subject. We've just laid out the ground rules. Fucking bollocks. I wish you got paid by the hour in this. I'm not sure how to structure this video, yeah? But I'll give you a clue. In fact, I'll tell you straight up, yes, I can structure it around my belief. Voltage optimisation is snake oil. It's a fucking waste of time, a waste of money, a waste of resources, a waste of big cores of copper for the majority of situations. It just does not fucking deliver what it promises, even though the promises sound quite Gucci. The problem with voltage optimisation is, outside of laboratory environments, where you maybe, I don't know, test the microwaves you claim to sell to the UK, why do you need 230 volts? The actual infrastructure required to maintain exactly 230 volts outweighs the benefits of what you would receive from a 230 volts on a larger scale. Otherwise, the electricity boards would do it. The electricity companies do it with transformers and tap changes, yeah? They do bring the voltage into line, no doubt about it, they use tap changers. They don't use voltage optimisation units. And like I say, outside of laboratories, why would you bother? That whole they'll save you loads of money routine, if I put a voltage optimiser on my kettle, when the voltage is higher, you use more electricity. Yeah? Fine. Heating is 100% efficient. So when I put it in the kettle, I use more electricity. But I use the kettle for a shorter amount of time to boil a volume of water. So with more voltage, the kettle boils quicker. If I provide a heater, the heater heats the room quicker. And if I use an oven, the oven cooks the food quicker because it's 100% efficient. If therefore I then install a voltage optimisation unit, the kettle boils slower, the oven takes longer to cook the food, the heater takes longer to heat the room. Therefore, I leave it on for longer. So any saving taken from the actual voltage being higher, using more electricity, is taken away by the fact it takes longer. So basically, with the raw heating appliances, we're just converting energy into another form of energy via an element of heating. The kettle, the toaster, the oven, they just take longer. You drop the voltage, they take longer, they use longer. So the saving of the voltage is overridden by the length of it. So you can rule all them out straight away. They are not good for voltage optimisation. The second one is switch mode power supplies, the things that are in your laptops, the things that are in your telly, the things that are in virtually fucking everything. Even the oven's got them the clock on, yeah? Yeah, fair play. They might work better and more efficiently at 230 volts because they may have been tuned electronically to operate better in that range. So when you put 230 volts in it, it produces a good solid 24 volts. When you put 237 volts in it, it still produces a good solid 24 volts. That energy is probably lost by heat. Yeah, so that heat you lose, because the switch mode power supply is providing 24 volts, the energy's got to go somewhere. So the heat you lose gets into your house. So fair play, the switch mode power supplies, it will save energy. But then the problem is, switch mode power supplies don't use fuck all anyway. I remember the TV would sit there in the corner buzzing away using 500 watts. Now it uses next to fuck all. So the areas it really saves you money on, the switch mode power supplies, is minimal. Then when you go to lighting, it's all fucking LED. So it's either LED, which means it's got a switch mode power supply in it that's minuscule, or it's fluorescent. Well, if you've got a hotel that's full of fluorescent lights, unless they're low frequency, they've still got stars and that in, they'll be high frequency. And if they're high frequency, they switch mode power supply, so it doesn't matter. The voltage doesn't matter. It optimises itself. So now you start to see like a lot of these things where it can save money. It will save money, but it's so small it doesn't matter. So what I've done there is I think what on Wikipedia is right, so have a read that and get to understand it. If you're heating something, it takes longer to use more electricity. Also, it's in the Wikipedia article amazingly, I was going to bring it up. Most people the efficient way to fit this, the cheap way that some company will flog you, is to fit it at your main incomer. So your main incomer comes in, you fit the voltage optimization, and then you feed all your existing supplies. Well, that means you're then optimizing the voltage for tons and tons of stuff that does not need its voltage optimizing. So in a hotel, for example, as I've seen recently when I'm on here, you're optimizing all the lighting. You don't need to do that. Then the entire kitchen, the ovens will just start taking longer. And if they're electric, assume they're electric, probably all gas in the kitchen, but the heating will start taking longer. All right, a large portion of your load in a building like that might be switch mode power supplies, but by the time you add all those power supplies up, does it equate to a fucking few kilowatts that is not worth your while anyway? So even in a very large building with a lot of switch mode power supplies, a huge office block, you have to ask yourself, would you just be better to buy better transformers for your laptops that are more optimised than that? I personally don't see the point in optimising a whole building's voltage just to benefit a few minor appliances. Then you've got the cost of the voltage optimisation unit, the fact that it's the size of a Ford fucking Fiesta and weighs about the same, all the cabling, the fact that your voltage is going through it, so you probably need a bypass switch unless you want that optimisation unit to blow up at some point and then take out your entire main supply. You've got a switch going, all that kind of stuff. So yeah, I just find them to be a real bit of a faff, if I'm honest. I don't think they're beneficial to anywhere but laboratories, or if you have a very specific application or a very good cost saving, if you installed it from new so that only the suppliers that fed that equipment run voltage optimisation, you might be onto a bit of a winner. Yeah, generally the ones you find for houses are fucking turd. They're little tiny fucking shitty things, not like they're going to blow up soon you look at them. I don't know if they work in series or parallel either. I know the bigger ones, you put them in series so you optimise the entire thing. You've got a weak point. To me, they're in the majority of normal buildings, normal houses, normal hotels, normal offices, normal fucking garages, all that, there's absolutely fucking no need for it. Even when I fitted them commercially for very specific reasons. For example, I have fitted voltage optimization units into laboratories and they were fucking huge because they were absolutely guaranteeing you was getting the 230 volts or whatever you select on the LCD display. They were monstrous things and they were used for feeding weighing scales on highly accurate weighing equipment for reasons that I don't even want to understand, yeah. So, yeah, let me know your opinions, yeah. I'm a no. The maintenance, installation and outlay required does not benefit the cost savings in the majority of applications. Yes, some of your power supplies may last longer. Yes, your house might get a bit less warm. There are benefits, but they're always skewed heavily on advertising, yeah? If you got eFix to say one, they do you a 4-hour video about how fucking great they are and say you sell me millions, yeah? You get me to do you one, I'll tell you straight up, yeah, they'll save you money, but not a fucking lot. So, yeah, do your own research. Anything else to add on that? Yeah, don't think there is. I think I've covered everything. But it's just bollocks, isn't it? It's just using maths, which you can never argue electrical maths. It's using maths to sell a point, but the point is tiny, I think. And if I get anything else, I'll tell you. But yeah, that's voltage optimization, kids. Don't do it. Just to add, if you are going to stick a massive, huge box in your switch room that's going to do something, don't pick voltage optimization. Probably pick power factor correction and then maintain it well. The amount of switch rooms I go in where there's a dusty fucking cabinet the size of a fucking double wardrobe in the corner with the non-working power factor correction in there is amazing. And that will actually save you some money, providing it's sized correctly, maintained correctly, and looked after. But the amount of times I go into plant rooms and there no one bothers with it, it was fitted when it was new, and it's just been left to rot, is unbelievable. So if you're going to look at power quality analysing, which I can do for you, give me a shout about that. I've got all my power quality analysing shit here, look. Do your power factor correction, because that will actually save you money by stopping the leading, the lagging, all that. So if you're going to go to a switch room and you see, go, that's what you want working, then mind your fucking doodally, wee-wah, woo-wah, voltage optimisation. But yeah, I forgot about that one. That's important. Don't ask me to explain power factor correction. In my experience, these power factor correction, which is a good thing, and these voltage optimisers get fitted and forgot about. People want to do the maths, the accountants want to do the maths, fit it, say it's going to save a fucking load of money, and then leave it, when in fact both of those items require maintenance yearly. If your power factor goes off, it's probably going to blow up, set the fire alarm off for the day, but you'll be able to bypass it. If your voltage optimisation goes off and it's in series, it's going to take your whole fucking build out, innit? You're going to have to get someone in to bypass it. So yeah, be aware. There's loads more to go out than this, but this is just like a brief overview. If I went real deep, I'd need someone to talk to. It's just for me talking to this camera before I was like it is now. But yeah, I might bring this up with on a podcast type thing I'm going to be doing. But yeah, voltage optimisation. The maths say yay, but the maths are telling me yes, but my mind's telling me no. It's embarrassing, isn't it? Don't know what I did that for. Couple of bits of additional to the voltage optimisation people put in. Someone's messaged me and said they're fitting one in a rural property next week because to keep getting voltage spikes keeps knocking their IT off. I'm not sure that's the best bit of kit to do that, because I don't know if the voltage optimizer can handle the spike itself. But it is, if it does do that, it is an application. Yeah, if you want to smooth out a nice, lovely voltage in your rural overhead line application, great. Personally, if that was me, I'd be making sure I had better than normal surge protection that I monitored more closely, and I'd probably be fitting like UPSs for my IT equipment, based on the fact that I'm just in a bad area on the end of a line. But yeah, I don't think there's a better way of doing that. Obviously, you won't fit a UPS on the mains though. You'd fit it on the sockets that the IT equipment was passed into. Yeah, you won't just optimise or UPS the entire lot. So that's interesting. Definitely surge protection one there though, I think. But yeah, interesting concept. Another one I've had mentioned to me, it was Kevin Chevron actually, because he just mentioned it conceptual. I didn't name the last one because it was a customer's house. The voltage optimisation, no matter where you put it, goes after your meter. So you're still buying all the voltage at whatever fucking voltage you flog it to you at before optimising it on your own side. So like, you're still paying for all the losses in the voltage optimiser, aren't you? So your electricity coming in no matter what is getting metered, and then you're doing it around the diddle-doo-dah, whatever you do to the voltage, but that's after your meter. So obviously there's loads of maths and science to look at there, but yeah, it's after your meter, so you're still paying for all that fucking energy, aren't you? Because you can't create or destroy it. The voltage optimiser's either making it right, making it wrong, adding it on, taking it off. It's got to do something with it. It'll still buzz and make heat, so it'll cost money to run. Someone's messaged me and says, I'm working in a laundry today. No, I'm not. It's about optimisation, see. The dirty clothes come down, and they go into the dirty clothes bags here. Then they go into the washing machine here and get washed. Then they come out and go on these racks. But I also hang clothes up on hangers like this. That way, they dry quicker. They get heat all round them, and they let moisture into the room, which moisturises the house because we have a wood burner. And then, when I want to hang them up, they're already fucking hung up. I'm optimising, I've totally streamlined my washing process into this area. So I don't go wandering around like that. Effing happens. Stood here. Close, wash, dry, hang, bosh. Optimisation. I'm all about that. Also, I know people say, no, how much washing do you have to do? Yeah, I used to do my washing on full moons only as well. Then I got a wife and 2 kids, and now I basically run a small Chinese-style laundry in the corner of my kitchen. Oi, Savoy, time for a bit of actual electrical content continuation. Let's talk about that. Just been in the office before, set up a label machine. I've got a sexy label that prints nice labels. They go on cable. You'll be seeing them later. But I actually want to start continuing some of the stuff I've started. Everyone that's messaging me, talking to me about wiring diagrams for pumps, yeah, I ain't forgot about you. It's just that the props I need to finish that video off are ongoing. Let me just tell you briefly about the nasty habit I have of starting videos and not finishing them. I have a nasty habit of starting videos and not finishing them. First one is, fucking hell, I can stay here. It rained at Forest at the weekend, so all the stuff's just lying on the floor drying out. I'll repack the bag. I have a nasty habit of starting videos and then wanting to make them perfect or educational or useful, so I don't finish them. So I remember I did this one about the pump switches. Well, there's the pump switches, look. You'll notice the pump switch are on a nice piece of wood ready to be wired up to something. And you'll notice last night in my story, I did a video about the motor core switches coming together. That's what I printed the labels for. So just going down to the workshop now to get some bits out, because I'm going to finish one of them this week, and I'll be able to bring the power supply, the levels and the motor board, and I'll be able to demonstrate how that works. I'm going to be demonstrating it just here in my little fucking recording area, and I'll be doing the diagram just here on the whiteboard. So anyone that's waiting for that one to come through, so I appreciate people bothered to speak to me on that one. Hold tight, it's coming. Right, so people think I have this nasty habit of not finishing stores. It's just that they are getting finished. It's just that I haven't had a chance to finish them yet. So that wiring one is on its way, but another one I started that I didn't get to finish at sort of went to store was this. This got sent to me by Adam Button Electrical, and in here there's a voltage optimisation unit which I covered a while ago in the story, and it's sort of part one of a YouTube, because I talked about it and said there was a bit cack. Aaron offered to send me this, and I was like, yeah, cheers mate, that'd be great. So let's crack it open and see what joys are inside. Maybe I'll set the tripod and do like a proper unboxing video like some fucking shitty YouTube wanker. Anyway, let's do that, and thanks Adam for sending it in. Thanks for all the people that offer to send stuff in as well, because I can't afford to go buying all this just to do actual electrical content. Here we go, I'm back to the call about an agency. Witching, motherfuckers! Give me your money! Anyhow, I don't like to just talk about stuff, I like to show it, so we'll crack this open. Cheers. Cheers for sending me this. So crack it open. I've obviously hidden my address so dickers don't come around the house. Not that this is my house. I couldn't open here, but on my channel I don't like to just talk about stuff where I can. I like to either explain it or show it. So this is a voltage optimizer. There's something in here as well. Is that a little touchscreen? Oh, that's a touchscreen for an ACS drive that he sent me as well. Cheers for that. Use for that. I've got the ACS 5, but not that one. So right, this is the voltage optimizer. Now let me get rid of all the cardboard and shit, and let's get into it, because it's not me saying it's shit, yeah, but I can prove it's probably shit. And I can prove that because I've got a £9,000 power quality analyzer at home which I can bring down. But let's have a look at how it works and just go over some of the ins and outs of it so we know what we're dealing with. Nice touch. I don't know if he's cut that out just for me, but I might save that on my wall, so I'll keep that. Cheers, one. Right, I've not looked in it. The screws are out. I've not looked in it. We're going to look at it together for the first time. So I'll flip the tripod round and we'll all look at it together and see what's held within. That's cheating it, but that's just a breaker. Let me turn you around. Right, in we go. Sorry about the lighting. I'm still working on the lighting here. It's made by Matt E. I don't know if you can see that. I don't look inside, but it's made by Matt E. I'll zoom in on there in a minute. Matt E make earth neutral pen protection units for EV chargers, don't they? It's got a Sendo on there. I don't know who they are. I will Google it after I've looked yet. And behind there, I've got a what I would describe as a dirty, cheap foreign breaker and a dirty, cheap foreign isolator. Don't know what that does. There's nothing more to look at the lid. So I'll just reset the video and we'll delve inside into the goodness inside. What's inside? Right then, I'm expecting it to be these, some electronics PCB and a toroidal transformer here, I think. Honestly, I looked. There'll be a toroidal transformer, round transformer, some electronics, and the breakers. Oops. Wow. There's a toroidal transformer. And there's no electronics. Well, how the fucking hell does that work? That's it. So you got... Oh, hang on, what's fucking going off here? Let's have a nose at this together. Fuck's sake. So... Oh, you're live in and you're live in here and you're neutral out. You're live out and you're neutral out of here. They're the outs. And that is the live in and the neutral in there. So they go in there, the neutral just goes straight through. I've got a pointer. There's someone on here that uses a little pointy hand. I'm very close to seeing that idea for myself. So yeah, we've got live out, neutral out. So these are the outgoing terminals, yeah? These are the incoming terminals. And all that does is put the live through a 63 amp.
MCB here.
And there's a little line flying off there, look, which goes to that. What is that? Is that some kind of reference voltage? I don't know how these transformers work, you know, but you've got a through the double pole breaker, you've got this little thin cable coming off at 63 amps and passing through there, so it can feed this little wire at 63 amps. That seems crazy. Why is that not? I know it's within an enclosure, so it doesn't need to be, but that seems an odd way of doing it. I don't know. What that little yellow wire does, I do not know. It's there, look. Let's cut these off. What we'll do is we'll face the fact that the neutral just goes straight through. It passes directly through, but there's a little lead here, look. Let's go up a little bit, look. So the neutral doesn't straight through. The neutral goes, most of the neutral goes straight through, but there's obviously some sort of reference here. And that goes down this cable here, and it goes down this little cable here. What is that? What is that? Is that some thermocouple that's embedded in there designed to trip it? I don't fucking know what's going off. I've not dealt with any of these transformers before, but clearly the majority of the neutral goes through. And the majority of the live goes down here into the transformer and back out. And then you've got this little control voltage bit here, which goes down here, and a neutral down there. So what's that powering? That must be powering something. What's that neutral for? Right, hold it there. Right, so I'm led to believe these are called voltage optimisation units. So I assumed that it would optimise my voltage. And I guessed that it would try and make whatever voltage is coming in, whether it's low or high, based on the, I think it's 6% and 10%, it's 217 to 253 volts you can have, that this would try and tie it up to 230 volts. But maybe it's not. I've just noticed a label on the side. Let me show you what that says. So the label says it's a model B60. I'm guessing it's 60 amps worth of doodah. And I'm guessing if you put this in a house, you don't wire it in series. You wire it in series, not in parallel. You put all your mains, tails in here. They go through and they come back out. So it restricts your house voltage, or the fuse board it's connected to 63 amps worth of doodah. It says input 235 to 253 at 50 hertz. And the output is the input less 18 volts. So does that mean it's just taking 18 volts straight off it? I don't know. The max load's 14 kVA. The MCB's 63. There's a load of bump down there about who it's made by, which is Matty in that. The problem is, the input of 235 to 253, let's talk about that for a minute. Stop me if I'm wrong here, yeah? Let me know, right? This box of tricks does this. So this voltage optimizer, as it's called, which has got no electronics in it. So I'm guessing, because there's no electronics in there, it can only do what it says on the tin. Whatever you put into it, between 235 volts and 253 volts, it reduces it by 18 volts. They're very important numbers because the UK voltage specification is, the minimum it can be in the UK is 217 volts, yeah? The ideal is 230, and the maximum it can be is 253. That's your voltage that's the electricity supply regulations, yeah? It's got to be between 217 and 253. That is why the voltage optimizer has a maximum usable voltage of 253. Well, hang on. That's no good, is it? That's not optimising my voltage. I'm so confused. If this is meant to optimise my voltage, yeah, but it only works within the UK specified voltages. So you can't plug it. If you've got over voltage, if you've got 260 volts in your house, this box is not ready to work on that. It's only ready to work up to 253 volts. So if you're suffering from over voltage, which really you need to get the DNO to deal with for you, it won't fix that. The reason it only goes down to 235 volts is because it takes 18 off. It just deducts 18, that's its job. At 235 volts going to your house, it'll reduce it to 217 volts, which is the minimum voltage you're allowed in the UK. So I'm not sure what it's doing. It's literally just dropping it by 18 volts. That's not optimisation. If I said I'm going to optimise your driving speed, you'd think I was going to keep you at 30, wouldn't you? Or 40 or 50 or whatever the road says. Probably the worst place for a cut like, yeah. If I was going to optimise your driving speed, I would optimise it so that you were driving at the maximum limit of the road you're on. So 30, 40, 50, 60 or 70, yeah? What this is saying is, oh, I'll just take 18 off. So that's like me saying, yeah, I'm going to optimise your voltage, mate. Oh, what do you do? Do you keep me at 30? No, mate, I just take 5 mile an hour off. So if you're doing 30, I drop you to 25. If you're doing 40, I drop you to 35. That is not optimisation. That is reduction. So maybe I'm dealing with, and I haven't checked because it will make a good video, Maybe I'm dealing with a voltage reduction unit. So what we're saying is, if you've got a voltage between these two, which is 18 volts above and the maximum permitted voltage, yeah, it will just drop at 18 volts. So therefore, because it drops at 18 volts, hang on a minute, we need some more mass on the screen, yeah? But just remember, I'll leave that up there, and this is the minimum. Yeah, let's go for some more volts. Let me do that maths. Right, I've done some maths. I've done it on my own because you probably don't give a fuck because you're not boring like I am, yeah? But I've just took an example of 13 amps, yeah? So 13 amps times by 217 volts, which is the lowest this will go, would give you a power usage at 13 amps of 2,821 watts. Then, adding 13 amps times 235, which is the maximum it can do, which gives you 3055 watts, which means on the bump on the paperwork, yeah, it's going to save you 234 watts. Well, fucking brilliant. That's like getting on for fucking 8%, isn't it, like that? So it's going to make everything I use 8% cheaper? Fuck me. Why don't we just drop the voltage to 1 volt? Oh, hang on a minute. Why don't we do that? Why don't we just drop the voltage to 150 volts? Then we'd save loads of fucking money, wouldn't we? Well, that's the secret sauce, isn't it? Let's have a little look at that. Now, this is our RC, yeah? These savings look fucking pretty good, don't they? If I said to you, instead of using just over 3,000 watts, you're going to use almost 234 watts less on something that's using 13 amps, you'd be like, fucking brilliant. And if you were using 130 amps, you'd be saving loads of money, wouldn't you? Ooh, I'm so excited, but why is there not one of these fuckers in every house then? There should be, shouldn't there? Well, here's the fucking fun bit, yeah? The way I see it is, you've got 2 types of load, but I'm going to use 3, yeah? You've got inductive loads. That's pretty much where something's moving, a motor. Don't worry too much about it, don't want to make it boring, yeah? You've got inductive loads. Now, I believe, genuinely, this will save money on some inductive loads, right? But, because they can run with less power. So inductive, maybe, yeah? Don't worry about resistive for a minute. We're going to come back to that. What about electronic loads? Right, electronic loads. That's, right, so... It all depends how many of these you've got in your house, doesn't it, yeah? Electronic, everyone's got them. Because back in the day, your TV was probably inductive and resistive or a bit of both, yeah? Now it's purely electronic. It's got electronics in it. It takes the voltage and reduces it. Those power supplies will work to an incredibly low voltage. If you get them out in the UK, they're probably for 230 volt. But a lot of laptop chargers, hang on, let me go and get a laptop charger. We're on a bit of a tangent here, but back in the day, if someone says something was a 230 volt AC power supply, you had to put 230 volts in it within the scope of the UK regs, yeah? This is a Dell one from about 7 years ago. This will accept 100 to 250 volts AC at 50 or 60 hertz, which pretty much means that on this end of the cable, which is a barrel adapter, whatever you put in there that you can find in the world, because no voltage in the world is below 100, no longer go over 250, it will produce the nice DC surge-free ripple current that you want there, no matter what you stick into it. And that is 7 years old, but it's a business one. It's probably designed for a traveller, yeah? This new Lenovo one is exactly the same. It says it will take 100 to 240 volts, 50 or 60 hertz, which again, you can take this, which pumps out the fantastic connector that is USB-C, and it will pump out the voltage that any of your USB devices need anywhere in the world. So what I'm saying is, basically, these electronics will work down to 100 volts. So we could have a 100 volt supply for these electronics and they wouldn't work more efficiently. However, it's not efficient to reduce our voltage with these pieces of shit because it's just not. These will then use more current. So are you saving out with electronics? Are you fucking bollocks? Anyhow, that leaves us with the resistive loads. Now, resistive loads are particularly interesting because this device that claims to save, I mean, if you thought about this 13 amp, that's going to be a fan heater in it, yeah, or a fucking bar heater or some sort of heating device or a kettle, it's going to save you that percentage, 8% every time you boil the kettle. Or is it? Let me tell you about that. Cut to the chase, yeah? If I fill this bucket with water and heat it with an electric element, it will need an amount of energy to boil it, yeah? Once it reaches boiling point, if I could record that amount of energy I put into it with electricity through that element, then I took it away, cooled it back down and put gas on the bottom, it would require exactly the same amount of energy to bring it to the boil with gas, because water is a constant and it requires the same amount of energy. Heating is a constant as well. You cannot just remove 234 watts of power and expect the same results. So basically, If you had this voltage optimization unit on your heating, your electric heating would be colder, so you'd leave it on for longer. Your kettle would take longer to boil, so you'd leave it on for longer. So you wouldn't actually save money, you'd probably slightly lose money because it'd be less efficient because it'd be doing a longer period of time. So it's all fucking bollocks snake oil, isn't it? Incandescent lights, filament lights, old lights that remember, they'll be dimmer because they are effectively little heaters. Fluorescent lights might run more efficiently, but the fluorescent lights contains loads of efficiency stuff anyway in the old style ballast. LED lights that have got power drivers in won't run more efficiently. Do not get me wrong, yeah? This will save you some money, but the minuscule amount of money it will save you compared to the maintenance of this, the purchase of this, the fitting of this, I personally don't think it's worth it. I would appreciate some comments below. You tell me what you think, or tell me if you think it's a load of bollocks. I think the snake oil, I think the upkeep, maintenance, installation and purchasing of something like this doesn't give any real savings whatsoever. So basically the conclusion is I see no real place for these, yeah? It can't be used when you've got over voltage because it doesn't function over voltage because it's designed to work on the UK grid, which means it's got to be within the right voltage range. All it will do is bring your voltage from the maximum down to this number, 235, or from 235 down to the minimum, 217. It doesn't have any electronics in it. It doesn't fluctuate with the voltage. If your incoming voltage goes up by 1 volt, the voltage on the outside of that goes up by 1 volt. So it's not like it's keeping it constantly at 230, because devices that do that are much bigger and do have a purpose in scientific labs and stuff. So yeah, if anyone tries to sell you a voltage optimization device, just be aware. These will stop things working. If you have 235 volts going to your house, this is taking 18 off, your inverter for your solar, your batteries or your PV might stop working. So yeah, they've always been snake oil. They're still snake oil now, except in very, very crazy environments. So that is my take on voltage optimization, yeah? I think it's a fucking scam. I appreciate I'm not going to get a load of feedback on Instagram about this because all the maths are the wrong way, but on YouTube I might. So I'm not going to call this part 1, but I'm going to call it like voltage optimization bullshit baffles brains or something, because yeah, I don't know. I'm not going to bother plugging that in because all it does is drop it by 18 volts. I don't see the point, yeah? We don't need to get the meters out to do that. And we've already gone through the fact that it doesn't give a fuck. So you ever go with your own maths, look at some of the maths I've done here, and do your own maths, see if it works. Then ever walk around your house and go, well, hang on, that computer, that's an electronic in it, that could probably work on any voltages. That switch, that's electronic. These lights, they're electronic. You're getting the feel for it, yeah? Very, very few things in your house now are inductive and resistive, and most things are just electronic. That heater is resistive. If I reduce the voltage to that, it'll be a little bit colder, so I'd have to leave it on for longer. So have a look around where you are and work out what your inductive, resistive and electronic loads are for. I've had a bit of feedback. I've got a couple of people, 3 people messaging me, but this one's done. This is a done deal from my man Sedge the Control System, saying something that I forgot to point out. The transformer will have losses in itself, and he's pointing me to, like I said, not much work with toroidal transformers. He's basically pointing me to a bit of stuff that says, even if they're 95% efficient, which they're not, they're about 90% efficient, on most arses, 10% of that energy that's being used to just drive that transformer is heat in the room. 10% is being lost through heat, which is probably more than you'd save. So in a normal domestic setting, actually having the unit is probably costing you money, especially in winter, in summer. God, I can't speak tonight. Especially in summer, where you're heating up a room that's already fucking boiling. So yeah, they're not efficient, and it's another nail in the coffin for these, I'm afraid. If the other conversations bear fruit, which they are doing pretty much, I've got some stuff to alert. Oh no, I've got to retake that. No, not really. Yeah, if the other ones bear fruit, I'll put them up as well. But efficiency is easy to lie about. There's a lot of things that are easy to lie about in maths. If you pick the right statistics and the right mathematics, you can lie about fucking virtually anything. Statistics are great, depending on which one you choose. So I'm well in the part that these are a load of bollocks, yeah? I don't think the cost of maintaining them is ever going to add up. The one thing, I've said this before, the one thing that does work is power factor correction on big sites. But you always see a big massive cover in the corner of the switch room, broken, not turned on, or with old capacitors in that's not working, and that is the one thing that will save you money. And if anyone's buying voltage optimization units over either purchasing power factor correction or maintaining their power factor correction, they're an idiot. But anyway, the other ones I'll add to this because it's interesting. I'm going to put this on YouTube now because it's an interesting snake oil load of bullshit, motherfucker. You know when you're doing a bit of B-roll for a video and you're like, if my fucking wife walks in now, she's going to wonder what the fuck is going off. Not because of the art, mainly because I've got my trousers off. Look. Nah, not really.